So welcome to this new lecture on statics ME106, and we were solving problems on centroid, center of mass and center of gravity. In the last lecture we did some problems by utilizing the integral formulation. We use the formulas associated with integration, and today we're going to look at problems of composite bodies. So here you are looking at a three-dimensional object that is composed of two simple volumes. Number one is cone and number two is hemisphere. So these two are connected together to form a composite volume, and densities of these volumes are defined. The hemisphere and the cone are made from materials having densities of 8 megagram per meter cube and 4 megagram per meter cube respectively. So this hemisphere, which is the volume number 2 here, has a density of 8 megagram per meter cube, and this cone that is designated as shape number 1 or volume number 1 is 4 megagram per meter cube, and the origin is defined at the intersection of these three axes. This is the origin, and remember that we have to measure everything from the origin. Now there is a clear distinction between this problem and the problems that we did in the last lecture. So in the last lecture you were given this kind of a shape maybe, and if you compare this area, this entity with this problem, you will see that here there is there is just single entity defined, single area. Okay, this is the single area defined here, but if you look at the present problem, you will see that it is not a single entity. It is basically composed of two different volumes, cone and hemisphere. So this is a composite shape, a composite body. This is we call a composite body, which is composed of different simple volumes and areas. So this is no longer a single entity. As we did some problems in the previous lecture, they were on single area. This is a connected system of bodies. So obviously this is different from the problems that we did last time, and there is one more thing missing here. In these problems you were given some kind of functions. Okay, so y was given as some kind of a function of x and vice versa, and here you can see that this information is also missing. So this clearly suggests that in these kind of problems we cannot use uh, the formulas that involve the integration. Okay, we cannot use the formulas that involves integration because there is no function defined, and since this is a volume we have to use dv now. So you use dv for volumes and da for areas. So we cannot use these formulas anymore because there is no function defined. So it's a composite body, and we will going to convert this integration sign for composite shapes, as we have learned, into summation sign. So this is z tilde and this is v divided by summation of v. So these formulas can be changed to the formulas for composite shapes, and so we cannot use integration now. We have to use this formulation, this kind of a formulation. So we have to identify each and every sub volume or sub area given to us, and we have to locate its centroid measured from O, the origin. So the first thing that you should now be able to note is that this given 3D object or volume is symmetric about the z-axis. So as you can see here that this is clearly symmetric about the z-axis. So therefore, z-axis is the axis of symmetry for this volume, for this object, for this body, and which means that the centroid, center of mass, and center of gravity, all three will going to lie on the z-axis. So we don't have to care about x-axis or y-axis. Everything will going to lie on this axis of symmetry. Centroid will lie on the z-axis, center of mass will lie on the z-axis, and this center of gravity will also going to lie on the z-axis. So we proceed on in solving this question. So first of all, let us extract some important things from the data given. The density of the hemisphere is 8 megagram per meter cube. The density of the cone is 4 megagram per meter cube. And some formulas will going to be very helpful in solving this problem. So for example, the volume of the cone is given by this equation 1 by 3 pi r square h. So this is the volume of the cone, and the centroid of the cone measured from its base, that is this point, is h by 4. So the centroid will lie on the z-axis. That is why it is z tilde c. So remember that tilde is basically the centroid of the your elements, okay, your differential element. So here we cannot use differential element, but we can subdivide our body into simple elements. So here z tilde for cone is defined as h by 4, measured from its base. And similarly, the volume of the hemisphere, which is the volume number 2, is 2 by 3 pi r cube. Okay, so these formulas will be helpful for us in solving this problem, and maybe these will be given to you in your exam. So the centroid of the hemisphere measured from this point, which is its inverted base, is 3 by 8 r, 3 by 8 times of the radius of the hemisphere, which is 100 millimeter. So you have to note this point, that the centroid of the cone is measured from this point, and the centroid of the hemisphere is also measured from this point, this red point. But this red point is not the origin. The origin is here, 100 millimeter below this red point, and we have to measure each and everything from this origin. So let us draw or complete a table, because these kind of problems of composite areas and composite volumes, composite bodies, are most easily solved if you can maintain a table. So since the center of mass will going to lie on the z-axis, because it is this volume is completely symmetrical about z-axis, everything will going to lie on the z-axis: centroid, center of mass, and center of gravity. So in order to find the center of mass of this composite volume, we have to use this formulation. So summation of all z tildes into the mass divided by summation of the mass. So we have two simple elements here. Number one is cone, number two is hemisphere. So here we have to calculate the product of uh, z tilde and m for each one of these volumes. And please remember that this z tilde is actually the center of mass for the individual volumes. But since the density of these individual uh, volumes remains constant. So for example, this hemisphere has a density of 8 megagram per meter cube, which is constant, and this cone is made up of a single material which has a density of 4 megagram per meter cube. So these ZMs or Z tilde M's rather will going to coincide with the Z tilde C. That is the centroid for the cone will be equal to the center of mass for the cone. Similarly, the centroid for the hemisphere, the Z coordinate of the centroid of the hemisphere will be equal to the center of mass of the hemisphere, because the density remains uniform within each volume, sub volume. So we have two shapes here, two volumes here. Number one is cone, number two is hemisphere, and we need to calculate their mass. So the first column is of mass. And how to calculate mass? Mass is simply density times volume. So density is given to us, and volume, we have the formulas for volumes as well. So we just have to substitute the values of radius of cone and radius of hemisphere here and get the volumes for individual objects, 3D objects. So number one is the cone. Let us start from the cone. Cone has a density of 4 megagram per meter cube. So I have written here 4 into 10 to the power minus 6, and I have multiplied it with the volume of the cone. So volume of the cone can be calculated using this formula 1 by 3 pi r square h, which means that r is the radius of the cone, which is 100 millimeters, and height of the cone is 300 millimeters. So you put all these values here and you get 3141592.654 millimeter cube. So this is, so we need to find out, because the density is actually given in megagram per meter cube. So we have to calculate the mass, which must be in kilograms. Therefore, we can write it like this. Let me show you here for one of this object cone. 4 megagram. So mega means 10 raised to the power 6. This comes into this goes into the gram. 4 raised to the power 6 gram. And so this is gram. We have to convert this into kilogram. So we have to divide this by 1000 as well. So this will be converted into kilogram per meter cube, right? And here we have the volume in millimeter cube. So we have to divide this volume, which is in millimeter, by 3 times by 1000 to convert it into meter cube. So kilogram per meter cube and meter cube will going to cancel out. So this is 3 times. And so you see that so this all together becomes 1 raised to the power 12 minus 12, and this is 6. So it reduces to 10 raised to the power minus 6. Okay, so this is how I have written 10 to the power minus 6 here. Therefore, you just have to write 4 megagram per meter cube, multiply it with 10 to the power minus 6, and multiply it with the volume in millimeter cube calculated from this formula, and this will going to directly give you result in kilogram. So similarly, you can find the mass for the hemisphere. The density of the hemisphere is 8 megagram per meter cube. So you have 8 into 10 to the power minus 6 multiplied by volume of the hemisphere, which you can calculate from this formula, 2 by 3 pi r cube. So you substitute the value of 100 in terms of r, and you get this value 2094395.102. And then the last row is about the sum. So you have to find the sum of all these masses, because the formula was actually this. The formula was, sorry, and summation of m. So we have to find the summation of m. Therefore, sum this column. It is 29.321 kilograms. The sum of this column. Now you also have to locate the centroid or center of mass of individual volumes. So let us move on to cone here, and we know that the centroid for cone is 1 by 4 of its height. So it is 300 divided by 4, okay, which is 75. But this 75 is measured from this point, the base of the cone. We have to measure everything from the origin. So we have to add 100 millimeters in this value to relate the centroid of the cone from the origin. So that is why 100 plus 75 gives you 175 millimeter measured from origin O. This is the centroid of the cone, and this centroid is also the center of gravity or center of mass of the cone, uh, because it is made up of single material only. The cone is made up of single material only. And so therefore, moving on to the hemisphere, we have to calculate the centroid of the hemisphere as well. And that centroid of the hemisphere will be measured from this point, this red point, and that is equal to 3 by 8 of r. 3 by 8 multiplied by the radius of the hemisphere. Okay, that is 37.5. But this is measured from this point r downwards, and we need to measure the centroid from this point O upwards. So we have to subtract this value of 37.5 from 100 to measure the centroid of the hemisphere from point O. That is why this is 100 minus 37.5, and it is 62.5 millimeters measured from O, the centroid or center of mass of the hemisphere. Both will be same because the hemisphere is made up of single material. So you have the centroid of each volume, and you have the mass of each volume. Now you need to calculate the product Z tilde into M. So you just multiply the value of this column with this column and write it down here. So 175 multiplied by the value of this column gives you 2199.114, and similarly 62.5 multiplied by the value of this column, this yes this box gives you 1047.197, and the unit will be kilogram millimeter, because this Z tilde is in millimeter and M is in kilogram. So the unit will be kilogram millimeter. And since you need to sum this product Z tilde M, you have to find the sum of this column, the sum of this column as well. So that will be 3246.311 kilogram millimeter. So looking at this formula, okay, we have this summation now, and we have the summation of masses now, so we can calculate the center of mass for this volume. So center of mass is summation of z tilde m upon summation of m. So 3246.311 or 307 is approximately 31 divided by 29.321 gives you 110.72 millimeters. So the center of mass of this composite volume measured from the origin O is 110.72 millimeters. Okay, and this is also the center of gravity. Why? Because this object is placed in uniform gravitational field. So uh, when the gravity is uniform, the center of mass will always going to coincide with the center of gravity. Therefore both are same and both will going to lie on the z axis only. So that is why you have noticed that I was not bothered to actually calculate uh, x bar m or y bar m, because there won't be any x bar m or y bar m in this problem, because this object, this volume is totally symmetric about the z axis, and so the only value that we shall be concerned about is z bar m. So you see that it will be very handy for you if you make this kind of a table while solving composite bodies and composite shapes, and these formulas will always be very important. So most of the time these formulas will be provided to you. Okay, but you have to show this table in your exam. You have to make this table. Okay, then use this formulation and get the value. So if I ask you to find the centroid of this composite volume, you have to change this table actually. So let's move on calculating the centroid of this 3D volume. So for centroid, because it is a three-dimensional volume, then you have to calculate, you have to use this formula. Okay, the centroid for this composite shape will be summation of z tilde into v divided by summation of v, and this v is basically the volume. So again you have to make a table here. Your volume 1 is still cone, your volume 2 is still hemisphere, and you have already calculated the centroid of the cone measured from the point O, the origin, the centroid of the hemisphere measured from the origin, and you can use these formulas again to calculate the volume you have already calculated in the previous uh, slide, previous table. So you just have to put that value here, and this time you have to calculate the product z into v, z tilde into v. Previously we calculated z tilde into m because we were trying to calculate center of mass. Now we are trying to calculate centroid, okay, which is the geometric center of the volume of this body. So no more z tilde m but z tilde v, because now we have to use this formula. Okay, previously we were using this formula. So see, summation z tilde m divided by summation of m, this is the center of mass. Okay, so the values of the centroid and the values of the volumes can be simply copied from this table to the table for centroid, but only the last column will going to change. Here we are calculating z tilde m, the product of z tilde m. Okay, the unit is kilogram millimeter, but here when we are trying to calculate the centroid, we are calculating the product z tilde v. So you have to multiply this with this value and enter into this column, then multiply this value with this value and enter into this column, and then according to this formulation you have to calculate the summation of this product z tilde v. So calculate the sum, this value plus this value. Okay, this gives you 680678408.025. millimeter 4. Actually, this is millimeter 4. Okay, and summation of V will be the addition of these two values, which is 5235987.753, and this is millimeter cube, and this is millimeter 4. So if you divide according to this formula, if you divide this value by this value, you will get 130 millimeters. And so you can notice that the centroid of this volume is not coinciding with the center of mass. And why is this so? I told you in the previous lecture the reason behind this is the fact that this volume, this total volume, this object, this body is made up of non-homogeneous material, because you notice that the cone is made up of a different density and hemisphere is made up of different density. So whenever material is non-homogeneous in your body, your centroid will not going to coincide with your center of mass or center of gravity. Centroid will be the geometric center of your body, while center of mass and center of gravity will shift towards the heavier material. That is why they are not coinciding with each other. So, so we have solved this problem, and you can notice that this problem, these kind of problems can be easily handled if you can make this table and enter the values required. So just looking at the formula that you will be using, you can construct the table. So in the formula, it is clearly shown that you need to find the product of z tilde and v. So there should be a column of z tilde v, and you have to find the summation of v. So there should be a column of v. And since you need to find z tilde into v, you have to list down z tildes as well. So just looking at the formula that you have to use, you can construct the table. So let us move on to the other problem now. This is 9-5959, and it is saying that locate the centroid xy of the composite area. Now, the first thing that you should note is that this area is not symmetrical. So its centroid will not going to lie on either the x-axis or the y-axis, because it is no longer symmetric. In the previous problem, the object that was given to us was completely symmetric about z-axis, so everything lies on the z-axis. But here we have to calculate uh, x bar and y bar separately, because this is not a symmetrical shape, and this is basically not a volume, this is an area. Okay, so we have to, by looking at this figure, we have to break this composite area into simple shapes. So for example, if we say that this entire uh, composite area uh, can be constructed, if we assume this entire rectangle and name it as 1. So this is our composite shape 1. Okay, this entire rectangle, and this small square is our shape 2. Then this triangle is our shape 3, and this quarter circle is our shape 4. So using these four different simpler shapes, okay, and their addition and subtraction can give us this area. That is our true area. So again, uh, these formulas will be required in solving this problem. We have uh, the area of the triangle defined as half into length into breadth, and the centroid of the triangle is defined as h by 3 from its thicker end. So where is the thicker end of this triangle? This is thinner, this is thinner, this is the thicker end. So from this point, the centroid in the x direction or in the y direction is defined as h by 3. What is h? This dimension. If you are looking at the x coordinate, then this is h. If you are looking at the y coordinate, then this is the h. And one third of this value gives you the centroid of the triangle measured from the thicker end. Then quarter circle, the area is pi r square upon 4, because it is the fourth part of a circle. So the area of circle is pi r square, therefore it will be pi r square upon 4. The centroid will be 4r upon 3 pi measured from the center of the circle, this point. It is 4r upon 3 pi, the centroid. Then for rectangle, things are very easy. Area is length into breadth, and the centroid will lie at the half of the dimensions, L by 2 and B by 2. Right. So we are basically calculating x bar first, the centroid, the x coordinate of the centroid for this composite area, and that is given by summation of x tilde a divided by summation of a. And a, this time we are using a because it is a area, it's not a volume. So let us construct the table for x bar. So we have, this time we have four sub areas, 1 2 3 4. So 1 2 3 4. Okay, first of all calculate the area in inch square. So the dimension is inch square. The unit we are using is English units. Okay, so area for shape number 1, that is your rectangle, this one. So its area is 7 into 6. So this dimension, this length is 4, and the radius of this quarter circle is 3. So this makes 7, and the radius of the quarter circle is 3, and this dimension is 3. So it is 6. 7 into 6. Okay, 42 inch square. And what about the centroid of this area? Okay, so you are calculating the x tildes for each one of these areas, and remember that x tildes will be calculated from origin. Everything has to be related from origin. So it is 7 by 2. Okay, 7 by 2 and plus this dimension 3. 7 by 2 plus 3, this gives you 6.5. So this is the x tilde measured for shape 1. Similarly, shape 2 is this square, which has an area of 3 into 3, 9 inches square, and its x tilde measured from the origin is 3 by 2. So 3 by 2 is 1.5. So 1.5 inch. Now shape number 3 is your triangle. So the area is half into length into breadth. So half into 3 into 3. That gives you 4.5. And its centroid will be, you can see, 1 by 3 of h. So from this point it is 1 by 3 into h, and this h is 3. So this is, from this point it is 1 inch, but you have to take the x tilde from origin. So 3 minus 1 gives you 2. That is why it is 2. Or you can say that from thinner edge the centroid is 2 by 3 of h. So it is 1 by 3 of h from thicker end and 2 by 3 of h from thinner end. So you can directly say that it is 2 by 3 of this side, which is 3 inches, measured from this point, thinner edge of the triangle. So it is 2 inches. And now this fourth shape, which was the quarter circle, basically it is not part of your, if you look at this original figure, this is not part of your area. So we have to basically subtract this portion of quarter circle. So the fourth area will be subtracted, and that is why it has a negative sign here. Okay, because originally this is not part of our uh, body. So we considered this entire rectangle as one, and from this rectangle we have to minus this quarter circle 4. So that is why it is minus here. The area is pi r square upon 4, which is 7.068 inch square, and its centroid is measured from this point, the center of the quarter circle, from this point in the direction of x. It will be 4r upon 3 pi. So 4r upon 3 pi is 1.273. Okay, from this point it is 1.273, but we have to measure it from the origin. So it will be 3 plus 4 and 3 minus 1.273, right? Because this dimension is 3, and this dimension, we say that this dimension is 1.273. So we have to basically subtract 1.273 from this dimension of 3. So this dimension is 3 inches. So from this 3 you subtract this value of 1.273, you get this one, and in this value, which is 3 minus 1.273, okay, this value is 3 minus 1.273, you add 4 and 3. So we are adding 4 and 3. So this is 8.727 measured from the origin. The centroid of this quarter circle measured from the origin is 8.727. Now the last column is the product of these two columns. So 42 into 6.5 gives you 273, 9 into 1.5 gives you 13.5, 4.5 into 2 gives you 9, and minus 7.068 into 8.727 gives you minus 61.682. Okay, so using this formula we have to calculate summation of A's. So this is the column for A, and you have to sum all these values: 42 plus 9 plus 4.5 minus 7.068. So please note that you have to sum this column according to the sign. Do not put a positive sign here. It is minus. It is minus, and it will always remain minus. This minus is carried here as well in the last column, if you can notice. So 42 plus 9 plus 4.5 minus 7.068 gives you 48.432. This is the summation of area column. And now you have to find out the summation of x tilde a, the product of x tilde a. These were the products of x tilde a. So you have to just sum them according to their sign. So 273 plus 13.5 plus 9 minus 61.682 gives you 233.818 inch cube. And using equation number 1, you divide this value to 33.818 divided by 48.432, and the x coordinate of the centroid of this composite area, of this entire composite area, comes out to be 4.827 inches. Okay, so similarly you will going to draw the table for y dash. Okay, so this is y dash. Now you are measuring y coordinate of the centroid of this area. Everything will going to remain the same. The areas will remain the same. Okay, no change in this column, but this time you will going to calculate y tildes for each and every sub area given here, 1 2 3 4. Okay, so let's look at this, how to calculate these y tildes. Again, shape number 1 is rectangle, so this is 3 inches. Okay, this side is 3 plus 3 6, so this is 3 inches. Y tilde measured from origin. Then for number 2, you have this dimension is 3, so 3 by 2, 3 by 2 is the y tilde for this shape, that is 1.5. And for the triangle, you can use h by 3 from the thicker end. From the thicker end of the triangle, the centroid is h by 3, which is uh, 3 by 3 actually, and then you have to add this value of 3 because you are calculating the centroid from the origin, please remember. So h by 3 plus 3 gives you 4, right? 3 upon 3 plus 3 is 4. And similarly, the centroid of this quarter circle measured from its center will be this value. Okay, and this is again 1.273, the same formula, 4r upon 3 pi measured from this point. So this is 1.2773, and this dimension is 3, the total is 3. So you will going to subtract 1.273 from 3 and add 3 to it. Okay, so adding 3 to the difference between 3 minus 1.273 gives you 4.727 inch measured from the origin. So we are doing it in a very similar way as we did in the for x. This dimension is 1.273, 1.273, and this dimension is 3. So you subtract 1.273 from this 3, you will come here. Okay, this is the centroid of this quarter circle measured from its center. You will come here, and then you have to add 3 to it to relate it to the origin. So it is 4.727 inches. And then again you take the product y tilde a. So this column multiplied by this column. So 42 into 3, 126, and 9 into 1.5, 13.5, 4.5 into 4, 18, and minus 7.068 into 4.727 gives you minus 33.410. Then according to this formula, y bar is equal to summation y tilde a upon summation of a. According to this formula, okay, you have to get the value of total area, and therefore again add them with respect to their signs, and you will get 48.432, the same result as you get in the previous slide. And summation y tilde a, so you add the values of this column with their sign. Please note that negative will remain negative, okay, while you are adding. So 126 plus 13.5 plus 18 minus 33.410 gives you 124.09 inch cube, and you divide this value by this value according to this formula, and you get the y coordinate of the centroid of this composite area, that is 2.563. Okay, sorry. So x was 4.827, it was 4.827, it was 4.827, and then y bar comes out to be 2.563. So this is your centroid, 4.827 inch. So this is your coordinates of centroid for this area. Okay, in the x it is 4.827 inches, and in the y it is 2.563. So this is 3 inches. So this must be somewhere here, 2.563, and this is 4.827. So this is the centroid of this composite area. And this is how you solve problems related to composite bodies. Okay, it is always very handy to make these tables. So without these tables, your calculations will be difficult to handle. So therefore, go through these problems thoroughly and try to solve the suggested problems when they will be uh, given to you. Thank you.